I've made you a host, John, so you're going to have to let latecomers in.
Okay, all right. Well, welcome everyone. Thanks for giving up your time and attending. Just to let you know that we now have the Pro version operating, which will allow us, or means that we don't have a time constraint, and it will allow some good time at the end for questions and answers and discussions. And really that's part of it, I guess, is to see one another, know that we're all still alive and well, and let's have a discussion on this, and it doesn't only have to be this. So over to Hennie. Hennie doesn't need any introduction. He's our stalwart in terms of setting up and running now weekly Zoom sessions. So thanks, Hennie, for all your hard work, and we look forward to your presentation. So off you go, and the rest of us will put off our videos and our sound, please. Thanks. Okay, Hennie.
Thank you, guys. As Monty Python said, Hitler, my part in his downfall. I'm going to just talk about my part in the construction of the Gautrain. So at the end of the day, we can discuss what's happening there. So the question has come up, what do we do about urban congestion? And my screen is frozen, so let me see if I can just get this one going again. There we go. So what are the options when we are getting to a peak traffic situation like we've been having between Pretoria and Johannesburg? Then the question is, the answer is go underground. Now, as you'll see at the bottom of the slide, I'm going to talk about mainly the section between Johannesburg Park Station and Marlborough, where the train comes out from under the tunnels. My part was between Rosebank and Marlborough, mainly between Sandton and Marlborough. And our offices were situated just off Sandton. So yeah, starting at Johannesburg Park Station, we did a lot of pre-investigation. As you know, with a project like this, there's a lot of investigation to be done. So that we're drilling in the streets beforehand and ongoing as we were going. We have to relocate all the services that's going to get in the way. We have to demolish obstacles, and you also have to look after nature. So you've got to try and rescue or keep the environment as good as you can while you're doing this. Going back to ground zero, after demolishing the area where we're going to put Park Station, the trucks started coming in and removing the rubble. We truck them up, basically, and again do some ground investigation, explore some more. Then install ground support, stealing horizontal cables. In lateral support, we start excavating, firstly by hand and mechanical excavation. And then as you go down, shotcrete and more drilling down, and support shotcrete and anchors. And there you can see Park Station, the excavation taking shape. And again, diverting major services in that area. We had to do special investigation. Oh yes, and the part that I need to mention as well, during the initial investigation or initial part, you've got to do a lot of instrumentation and also do a pre-survey of the area so that you can survey buildings and you can adjudicate any claims and assess the claims if they come in of any damage. So all the structures and buildings in the area, plus these instrumentation points to see if there are any movements due to the underground excavation. And there you see from a bird's eye view of the excavation at Park Street going down. And those services I showed you just now, there they are suspended above the Concourse roof. Now, as I said to you, the tunneling part between Park and Rosebank I wasn't part of, so we will jump straight to Rosebank, where the same Rosebank sitting in the mid from that little point there, where the same sort of activities started taking place. Again, diverting services, broadening the road so that, and diverting services, putting them in a place more accessible. And we then went into the suburb itself, into the smaller streets where we had to cut off some of the streets, isolate them, where we were going, and again, broaden the road so that we can divert traffic. Traffic control was one of the key issues we had. Some more demolition in the area, diverting traffic around the Rosebank shopping mall. There you can see the one-way traffic with the pedestrian bridge suspended in the air there, ready to go across our excavation. The mall did suffer a little bit of turned down, almost like not as bad as the COVID at the moment, but there you see at the same area, you can see my cursor, the pedestrian bridge connecting this part of the suburb to the mall. And this long stretch here is the Rosebank station to be at that point in time. Establishing there's a batching plant, we're going to do on-site batching of their concrete that and shotcrete that they were using. Then start the drilling of the soldier piles that was going to form the outside perimeter of the station in this case. In this case, it's soldier piles that went down. These are the steel reinforcing of the piles being lifted, so you can typically see by looking at the size of the people there, what the length of these piles are that are pre-drilled. And there the one is being posted erect to be lowered down into such a pile. And there's a pile rig on the side here, drilling the rig, lowering the steel into it. There's the northern end of the station taking shape with the trucks starting to muck. And there's the batching station in the background there, the concrete. And in the front here is some of the aggregates that's been brought in for construction. Here, the tops of the piles with the steel along the edge of the station, and an excavation now slowly but surely starting to take shape. As we expose the piles, these are the piles there, you'll see them marked off for, we have to retain them with horizontally drilled anchors. And as it's going down, we have to lower, at my end of where the camera is, we lower, they come in and then start excavating, and their Frankie pile is still busy drilling the lateral excavation. You see the two rigs, one in the corner there and one over here, drilling the lateral anchors, retaining these. There you can see the heads of the anchors in rows that have been drilled, and the ones being installed at the bottom there, and the new ones being drilled in these positions going down. And while over here, the excavator is maintaining a ramp for access. Going on with it, there you can see some more of the support going in, support being the critical part, while the capping beam over the top. This is the part at the top, which is the only part that is sort of fully concreted. The collar that we before the station. There's some existing services over there that had to be carefully excavated, preserved before they were cut off and diverted on each end. Still further going down, some more drilling, some more anchoring putting as we go down with the excavation there. We're almost at the bottom with the tunnel that's going to be coming in at that position over there somewhere, with all the anchors and the soldier piles standing next to each other. Then came the choice from Rosebank to the south. They decided to do it with a T.B.M. Now this, just to show you the choice of T.B.Ms, that like the one that we initially used, only who we call the open face T.B.M. These things typically in excess of 100 meters, but fully back up. We discussed last week T.B.M, so I'm not going to dwell too long on the T.B.Ms, just an idea of, again, of how they work. This is the single shield E.P.B T.B.M. And if those of you who do not know what E.P.B T.B.M stands for, it is Earth Pressure Balanced Tunnel Boring Machine. So those are the acronyms. Working with up to 400 bar, maintaining. This is the machine that we actually chose to use at Rosebank going south for about 4 or 5 kilometers. Then, as we discussed last week, there's the ring building phase. There, over there, you can see the concrete ring being constructed. Once the ring is in, then the machine starts drilling again. The machine, typically what it looks like, it conveys the muck from the front on that red line there onto a conveyor belt inside the machine, and drops it off on a conveyor belt that is suspended in the tunnel. So there's a machine belt, the cross belt, and the tunnel belt taking the muck outside. removing the muck. And this is the end product that we end up with the Gautrain. Typically what it looks like in one of these metro rail towns. Every so many meters, 500 I think maximum, we've got to have an emergency exit shaft in case there are any problems in the tunnel, by which you can evacuate passengers and also to do servicing. This one is in a side street in Rosebank. Now here you can see it looks all neat and tidy, but imagine the space, the limited space that we had to do this machine. Black off the street to public. We go in there, start again replacing essential services, and then there you can see the outline of the shafts. We start digging up the tarmac in the middle of the road, and shortly afterwards the tunnel is taking shape after it's been shotcreted, being excavated by excavator the initial couple of meters, and then there is again the collar, the top ring being cast in place by normal shaft sinking methods. So the steel going in, concrete being brought in, and then they brought in some heavy cranes to bring in the stage. This is normal shaft sinking stage. There you can see it's suspended on the collar by cables. These three winders there that lower this whole stage as they go down, with in the middle a square opening that can be closed, so you're on a platform going down, and through that gap then you bring out the muck in what they call a E.P.B. These little holes on the side here is what the people can step onto at the bottom if they want to get in. They also sometimes travel to the bottom inside this bucket. Okay, there you can see them emptying the bucket in a truck, a mucking truck. Now you ask yourself, this truck is going to back up all the way down Little Street? No, the guys get innovative. They put a turntable in, like the old gramophone records we had, and as the truck is full, you get a couple of guys just to turn it around and off it drives with the muck. This is a top-down view of that very stage that I showed you just now, going down with the shotcrete lining and the anchors and the weeping holes where you allow in some of the moisture to come through. And right at the bottom there, the guys at the bottom of the excavation. Here is from the bottom up, they're standing at the bottom, and on the side here is where the new tunnel is about to take off. Or no, there's a side tunnel, sorry, you go side tunnel to the main tunnel. So this is slightly offset from the main tunnel, obviously, and then you go about 50 meters, then you go up to the surface from there. This is just another good photographic shot. There's the surface outside there, taken from the bottom. Now, we move to Sandton Station, where all the big action took place. See in the area behind Sandton City, this is the hotel there, and there's the street, and there's the mall on the right. There in the background is where the new station was to take place, with the library over there, and street at the back there, which we were going to start diverting traffic. And there's a whole lot of work to be done before we go in there. First of all, there's a taxi rank that we have to consider and give these people, maintain access for all the commuters that still had to come in. There's the city library, Sandton City in the background. Some of the parking lot for people coming to the hotel, and the taxi rank nearing completion. Once it's completed, you can see the taxis are back in service, and they can orderly come and pick up their passengers and off they go. Without much of a hitch, we had everybody in consultation. We had a whole department consulting with the public, including the taxi. Now, because of the high water level above the granites in Sandton, Sandton is mainly on starts in decomposed granites. There's a whole lot of water that we had to contend with. They decided to put a diaphragm wall. Diaphragm, basically what it says, it keeps the water outside. So, but to do this, you have to use special equipment that was brought in. Well, these you don't see the scale of it yet, except if you look on the side here. But there's a whole plant that's associated with it. And to use the key factor using diaphragm wall installation is you've got to keep that slot that you dig open. And what they do, they use bentonite. And there are the bentonite dams that they use to thin them down and thicken them up so that they actually act as a support. It's a liquid through which, and then you float the bentonite off once you've dug. This is just what they call a clamshell grab, taking out a square bite in the beginning. When you dig the first part of it there on the left picture, is what they call stage one. You take 2 bites next to each other with this bentonite grab, with a clamshell grab, and then when it gets to about that depth, the big cutter comes in. This is a massively long tool, and here you can see as it cuts down right stage 2 and stage 3, it takes out the little middle bites, leaving, if you look in plan at the top there, you see the panels and the successive panels. Now, between the 2 pieces of concrete that you put in there, you also need to put in a seal. Again, here it is, where you put down the water stops in between these things with a clamshell grab going down, mucking up. And the gray area you see is this excavation filled with bentonite before and then they put in the steelwork. This is the steelwork, the reinforcing, and then they put a pipe down to the bottom there through which they tremie the concrete. This spotted area is the concrete being tremmed in, while the bentonite is floated off to the top, ending up with a complete concrete slab wall with a rubber water stop in between. This is, and while you're doing this, you know, you've got to creating muck within the bentonite while you're cutting. So you've got to recycle the bentonite all the time, clean it up on this machine here, separate the muck on the right here, let it come out, and then recycle the bentonite. So there it's going through this, the dumpster sand there in stage number 6. Number 4 is the bentonite going back into the hole. And over here at point number 9 is where you're bringing fresh bentonite. So you can keep on mixing new bentonite into this. And so this is what they call the desanding. This machine that they use, you can actually steer it. There's a steering component at the top here. So if you're going offline slightly, you can, by exerting, see the red circle here, by exerting pressure on the left or the right, you can change the direction. And as the graphic shows you, you can actually change and realign if you're going off direction. So you can fairly good accurate. Now the depth of Sandton Station is what they call sort of acceptable social limits in terms of safety, but it's one of the deepest stations that you find around the world. It's at 45 meters. Now you see the steel work that's gone in there to founding level is massively high, and you need special equipment to come and lift it up. There's the steel work of one of the panels being lifted, and you see how it walks the people at the bottom here, vertically lifted in, then let in, and there you see the bentonite into which it's lowered. This is the steel work inside there with the bentonite ready now for the concrete to be pumped in. There is just a picture of the water seal between panels that is put in place. There you can see the rubber, there's the sketch of it, where the 2 adjoining panels are then separated and water isolated by this rubber seal on the joint water. And here's a close-up of that seal with the bentonite on the side here, and there's a already cast concrete slab on the other side. And that way, and here's the steel work with which it's installed, which they then remove as soon as the concrete is set. Sandton Station was then done on the ground. You can see these massive rigs. There's one of these the rigs of the D-frame, what we call it, the diaphragm bore rig, with the steel work in the foreground here being erected and put together. And here's the machine actually doing its work, going cutting down panel by panel. And just to show you the scale of things with the teeth, this is the contractor's engineer standing on the edge. This is where the machine has been cutting at, where his toes are across there. That's the wall of the station. The steel work again being lifted up and lowered in bit by bit. And once it's all done, this is now Sandton Station in the making. We started with the excavation, as we've done on all the other ones. Go down, and then as soon as they get onto hard rock, they also did some blasting. The blasting they had to carefully coordinate so that, and do it in small little bites and off hours so that we don't disturb the residents too much, also not to cause so much any damage to the area. So highly controlled blasting to do this. This is just the station going down in stages, and as they go down, they put in floor by floor. If this is top down and not bottom up, as they say, you construct the station as you go down, ending up with it finished as you get to the bottom. Leaking it out, and this is a sketch which the architect, which they stuck fairly closely to. If you look at the end product, this is what it looked like, and this is a side section with the escalators going down to the 3 lanes of trains coming down at the bottom at 2 levels. Right, now that is as far as Sandton's concerned. Now we head to Mushroom Park, which was an interim station or an interim excavation to break up the length, because it's quite a long length between where the train emerges at the far end in Marlborough, as from Sandton Station. Mushroom Park, there you can see the excavation in a natural park, so we had to be very careful and close everything, make sure that nothing got done, none of the wastewater got out of there and to contaminate the area. The area was very carefully isolated, and then we started the shaft as we did with all the other shafts. It was a circular shaft initially. Then when we got to about this depth, they realized that this was not going to work. The equipment that they were wanting to put down there didn't fit into the shaft. So we said, okay, back to the drawing board. And so we made a square shaft. Fold it back up. This is one of the small errors we made there. Fold it back up and then made a shaft to size, a square one that would take all the equipment. And lower down the excavators, and off we went digging it down until we got onto hard granite again and started with a small blasting excavation until we, and here you can see a big picker being lower down and taken up. There's the Sandton city at the top corner. You see where the BMW. So we're right close and next to all the ongoing industry. This is Mushroom Park offices. We had to optimize the space by putting buildings, containers on top of each other so we can all get in there. This is now drilling, starting to drill the side for the tunnels going in. Here are some of the blocks, explosive loaded, ready to go. And then they blasted in small little bites. Again, as I say, in times when the people are asleep, basically, and when the offices are closed. That is one of the first blasts going off towards Sandton. And in they go to start installing the red line here is the outline of the tunnel to be. So first they take a small cut in the middle, then they start excavating some more, and then they start profiling it so that you get to the full size of the excavation. Installing horizontal, this is drilling the holes for the support, and there's the pilot tunnel going through the middle, just so that you can see ahead of yourself what the ground conditions are like, and also to facilitate the easier installation of support, because it's quite a wide span of rock. Looking from the other tunnel going to the north, standing inside that, you can see across the open excavation to the far side where the people are up against the face there, and that's where they are installing explosives. And here in the bottom they are doing the usual mucking into a kibble, which is then hoisted to the top and dumped into a bin, where it is again in the normal fashion taken off by road transport. Moving on to Marlborough Portal, because this tunnel from Sandton to Marlborough was done drill and blast. It wasn't done by T.B.M. It was done purely by blast. And coming here to Marlborough, it was very soft ground, highly weathered ground, and we had to employ some different methods of support here, so I'll just touch on quickly. Going down, they did some lateral support again, drilling ahead of the face, excavating down, and you can see there's quite a fairly flat slope on the outside. This is what they call a pipe roof. You drill steel pipes horizontally 10 to 15 meters, like an umbrella of pipe, steel pipes that you drill in there. They're all numbered, and they will be going in, numbers around there, and the position that they're actually being drilled in. Installing these horizontal steel pipes, then they go in and excavate around the inside until they get to fairly hard rock. You can see them excavating fairly soft rock, and they start putting in, these are steel arches. Then they put in a steel arch below these pipe supports that are in there. There you can see the pipe support sticking out there with the ribs, steel ribs coming in at about 300 millimeters to 500 millimeters. What you see in here is a glass fiber rock bolt that they drill into the face to keep the face from falling on you. There's one dangling out here. So these are sacrificial ones. They actually destroy them as they excavate and blast, just to keep the temporary support. Again, when you come to near the end of your steel pipe umbrella, off they go again and mark off. Here you can see 28 of them being installed, these pipe supports. In they go again, they drill them, and underneath it, they put in the next steel rib. And again, there you can continue with your shotcrete face, put in these sacrificial rock bolts to keep the face from falling down on you. And so here you can see the successive blasts as they've been going in and installing shotcrete and rock bolts and roof bolts as they go. Now, this is a very carefully planned and calculated blast, electronically going off in sequences so that it causes minimum ground vibration. This is face being charged up. The guy there with his lighter, now he's just showing you, because it's distantly, remotely set up. It's not like the Overberg light and run. Just showing us there's the cut. These holes are drilled in the middle, so that there's a breaking point for the rock to start moving into once the explosion goes off. And there you can see the explosion has just gone off and there's a dust coming out from the tunnel. And then as soon as the muck is cleared, we send in our guys, the technicals, to go and evaluate the rock conditions. We use the Q system, where we give it a certain Q range of value, and according to the value that comes out of there, we then adjudicate how many rock balls per square meter and how they go. So there's a certain predetermined pattern of rock balls going into the rock laterally, decided by the current rock conditions. And we have several geologists on shift to make sure that these things are actually very strictly adhered to. There you can see them installing some of the rock bolts and face support. Here they're tightening, this guy's tightening a rock bolt, one of these rock bolts, before they shotcrete them over. Just to, then the best advance that we got there was 10 meters a day. These are the service pipes going to the front with water and electricity, all of the equipment that they use in the front, and drilling jumbos. We had to, whenever we found water, then you start putting in these covering strips, water barriers that would then be shotcreted again later on, because the tunnel would be lined after this. This is just the initial support, the shotcrete. There you can see the strips that are channeling the water down to the bottom into a slot at the bottom, which can then be pumped out. If we do not succeed in completely sealing off the water, we make sure there's just Ed Schultz, my boss at the time. This is the guy from Gautrain, Andre, and myself in the tunnel going to inspect and see that these guys are doing their job well. And this is a aerial picture of where the train would emerge. This is going to the end, to the highway at Marlborough, and the view from the top collar here of the future train emerging from Marlborough. Thank you very much, guys. That's the part that I've done, and now it's open to questions.
Thanks, Hennie. Everyone can put their mics on, and we'll try the videos as well. Do I have to unmute people? Unmute.
Yeah, they can unmute themselves, or you can unmute them all.
John, are you unmuted? Where's
Okay.
all? Okay.
If you look under participants and you want to have something to say, you put your hand up and we can answer your questions.
Okay, who've we got questions?
I see Ed Schultz also came in. Ed, I hope you enjoyed it and that I didn't use too much of my poetic license. Okay, looks like you guys got no questions. I must have
I have. I raised my hand.
Oh, I see. Okay, maybe you must give me back the hosting, John.
Yeah. Where do I find that?
Peter's got his hand up. Just click on my name, and then it says more. Then you say hand back hosting.
Yeah.
Okay, Peter, your hand is up. Speak to us.
Hennie, in retrospect, the drill and blast, was that the right way to go for the Marlborough section? I'm just thinking, I understand the Lesotho Highlands, and Tony may be able to give us more information there. In the end, the sort of tunneling through the sandstones was actually much more successful than the tunneling through the basalts in retrospect. Would it not have been better to do it with a T.B.M to go to that Marlborough section?
Tony, would you care to answer that for us before we put Adrian on?
Yeah. Can you hear me? Am I?
Yes.
Okay. Look, if you go back to the actual history of it, it's quite interesting because we had two potential bidding groups, Haliwe and Bombela, and Haliwe were in fact wanting to use hard rock T.B.Ms over the full length of the route from Park through to the portal there at Marlborough. And they would have, in fact, between Park Station and Rosebank, they would have taken a much lower vertical alignment, which would have kept them in the hard rock. So that was the one proposal. And then the alternative proposal was the one that you've been describing, whereby from Park Station going north, you had Bombela going down through the Parktown trails and quartzites and so on. And before you came at the bottom there of the hill, you then came into this decomposed granite, where you use the E.P.B T.B.M through to Rosebank, and then from there you then chose to drill and blast through from there right the way through to Santon, the Santon Cavern, and on to, as you say, to the Marlborough portal. So, you know, different people have different ideas, and you know, you adapt your alignment, your route for physical reasons and geological reasons. So it could have been done. It could have been done differently.
Yeah, and just to come in there, you know, they said that the sort of economical length for a tunnel is around about 6 kilometers. So there was always debate why they did such a short length of T.B.M at you know, in Santon, because you've got to actually have sufficient length to pay it, because it's a massively costly machine. Adrian, you had your hand up.
Yeah, well, that was my first question. So that's sort of half answered. Difficult, I guess, even in retrospect, to say which would have been the best. The other question was on sinking those little shafts. Did you use all Basotho on that, like they do in the mines?
Yes.
They're a tough crew, aren't they?
They are a specialist in shaft sinking. So they sort of tend to, because they come with a CV, you know, that's already tells you that they can do it. So by default, basically.
Right. Can I just come back briefly from the point of view that, of course, compared with mining operations, the shafts there for Gautrain were very, very shallow.
Sure.
And I'd like to pick up on an earlier remark that you made, Adrian, about the tunneling in Lesotho, where you seem to think that the T.B.Ms were more effective in the sandstones than in the basalt. And I don't quite understand why you should have thought that. because
I think that was Peter.
Oh, sorry, whatever it was. I mean, we had very, very successful tunneling in the basalt with T.B.M.
My point was more, Tony, about the lining, whether to line or not. Eventually, the lining was far more expensive because it had to be done retroactively, I think, for large parts in the basalt, whereas it was done straight away in the sandstone. But I mean, you are much more au fait with that, so please give us the full picture.
That's quite right. It was with the sandstone tunneling, it was decided from the start they would line it, and they used a precast element system, which was also again used on the Mahali tunnel later on. And in the case of the basalt, there was a tremendous amount of research and development work done as that tunnel was being developed, because it was thought initially that the basalt tunnels could be largely left unlined. And in fact, at the end of the day, it was a very, very difficult decision as to what to do, because there were quite definitely problems with the durability of the basalts. Some of them, the amygdaloidal basalts were problematic, but you had long lengths of tunnel which were in the non-amygdaloidal basalt, and up to a kilometre length could have been left unlined. But the trouble was that we couldn't really get a good enough hold quickly enough to make a reasoned decision on how much of the tunnel could be left unlined. And that led to time pressures to having to make the decision to line the tunnel with an in situ lining after the excavation.
Yeah, I was going to say, just to add there, John Bristow, I mean, in the basalts, it's always difficult, and it depends, as you say, Tony, what sort of basalts and where you were in the basalt, because, you know, some of the basalt, certainly in the middle of flows, will be, you know, more like a dolerite and quite cohesive or quite robust. But once you get into the flow contacts and the amygdaloidal parts, they come apart very quickly.
No, you're quite right. Also, it depends on where you are in the basalt pile.
Yeah.
And of course, the gradient of the tunnel.
Yeah.
Very flat gradient, so the northern part of the tunnel was tended to be rather better than the part from the intake.
Good. And just another question while I'm going, Mushroom Station, would that become a station of the future, or is that sort of a portal that allowed you better access in this long horizontal development you were doing?
No, that was just a temporary work situation, a convenient point from which to work.
Okay. Good. And last question: the drilling and blasting, is that cheaper than the tunnel boring machines, or is it really get back to the strata that you're in?
Oh, it's different people have different.
Okay, so it's really just choice choice of approach.
It also depends on the length of your drives. If you've got really long lengths of tunnel drive, then a T.B.M will undoubtedly be cheaper.
Okay, but, fair enough.
The drives on Gautrain were relatively short, and you can have many more faces being excavated at the same time, so that you can in fact negate the counter the very relative fast speeds of tunneling with a T.B.M. If you've got a number of different points of attack, drill and blast, you can overall achieve the same sort of progress.
Okay, thanks.
Yeah, just, you know, on method of excavation, as a drill and blast guy from the mines and the tunnels, when I went to the Middle East and found that explosives are basically prohibited, you know, we as South African tunnelers were frustrated at the fact that we couldn't use explosives there, because they were going at such a nail-bitingly slow paint drying watching method by cherry picking. So they have 100 of these cherry pickers pecking away at the limestone, where we said, man, you just go in there, bore and blast, and we will have this thing finished in 2 weeks. It just wasn't to be done. So you start developing this art of cherry picking for fine art. You know, you actually get quite a bit of advance doing it like that in a safer way. So you change your mind as you go along.
Okay, Adrian.
That's all from me, thanks, John. That's just quite funny.
Adrian, I need to talk to you about that beautiful background that you've got there. How do you set that up? Are you actually?
You got it. Well, you got to have
Glacier.
a glacier in Alaska. One of these funny things where you walk along it and there's stakes put in the ground that tell you where the snout of the glacier was back in time, right? So I think the first stake in there is 1880 or something like that. So from 1880, it's been retreating back to its current level. So, you know, we had a giggle about global warming when we saw something like that. You know, the retreat of glaciers is not, it's dependent on a lot of things. And that one's been going back for more than 100 years. Hennie, it's down at the bottom. You see next to your camera?
Yes.
Cameras, there's an up arrow.
Yeah.
If you just click on that up arrow and it says choose virtual background.
I see. Okay.
So if you click on that,
that's great. Fine.
there's a couple of different.
I see. It plays a bit of havoc with your hairstyle at times. Otherwise,
it does when you move like that.
Yeah.
Funny things happen.
That's a beautiful thing to see. Oh, no, that's great. Yeah. Thank you very much for that tip. We learned it because this is the new world we're going to be communicating for a while now. So
you've got some
standard for the occasion.
You've got some standard backgrounds in there, but then you can pull your own ones in. So if you want a background of dogs or something like that, you can do that as well.
Okay. That's great. So that's beautiful.
Right. Any other questions? Did you unmute everyone, or are those people sort of elected to mute themselves, Hennie?
Yeah, no, I've asked them to mute themselves, and we haven't heard from Gert or John or anybody like that yet. Any other questions, guys?
Any other questions? Okay.
A brilliant presentation, Hennie. Well done.
This presentation is available. If you just want to look at the slides or refer to something, we'll have a link to the cloud where you can actually download and check on it if you want. Thank you very much for coming. Do you want to say something about next week's presentation, John?
Yeah, so we're getting on a roll now. Next week we will go back to diamonds and economic stuff. So Mike Diverted is going to talk about the exploration and discovery of Botswana's two big elephant kimberlites, and you know, the subsequent development of Botswana, one of the successful black countries of Africa. So and then I will also probably by tomorrow just put out a monthly note just on what's been going on amongst the group. John Blaine and Dave Morant and Mike Dormer are still ongoing, doing good work with the sort of with the guidebook and the geological tour that we want to set up from sort of Gordons Bay all the way around to Gansbaai, with a diversion up the Wine Valley. So in the course of your excursion or drives along this geological route, you can also pop up for a glass of wine up at the valley. So there's a fair bit of stuff ongoing, and I'll give you an update on that, and then I'll also put out the schedule of talks for the rest of the month. But thanks everyone, thanks for your inputs and contributions. Thanks Tony, we really appreciate your contribution as well.
No, I thoroughly enjoyed it. Thanks.
And if any of you new guys would like to be on our database, please drop me an email and I will put you there so that you can see our upcoming talks. We're a free and open society, so feel free to join us.
And Hennie, has everyone got your email address?
It's hennie.greeff@gmail.com.
Okay, everyone get that. Thanks, everyone. And
Thanks
if
a
any
lot.
of you, if any of you, I have now got a nice list of talks. Thanks, Adrian, for yours. And anyone else, has topics, and it doesn't have to be, high tech. People's excursions to strange parts of the world, doing geology. We're going to get Evan to talk on his work in Pakistan, for example, where he also went looking to build a cement factory. So anything of interest, we'd really welcome your contributions. And I'm sure some of you in your travels and geological careers have had great experiences, seen special places. So we welcome your contribution. But thanks, everyone.
Thank
Enjoy
you.
your day.
Thank you.
Cheers, guys.
Thanks, Hennie.
Thank you. Have a good day. Bye-bye then.
Bye now.
Bye all.